astăzi, într-o zi așa de frumoasă afară, într-o sală întunecată de conferințe la hotel. Faptul că sunteți aici sâmbătă la 2 după masă îmi dă multă încredere într-un viitor luminos pentru sectorul IT din Cluj. Sunteți aici să învățați despre cloud în general și despre machine learning în particular. Dacă e ok cu toată lumea, o să trec în engleză. Motiv foarte bun pentru asta. În sală este șeful meu, care nu vorbește română. Fericirea lui e foarte importantă pentru mine. El știe câțiva termeni cheie, știe bere nefiltrată, știe apă minerală, deci într-un bar se descurcă perfect, la o prezentare tehnică mai puțin. So if it's all right with everybody, I'm going to switch to English. Right? Oh, almost forgot. I am expecting you guys to be very interactive. And in order for you guys to do that, I brought candy. This, and not only that, I brought a lot of it. So you're going to have to be very interactive. I'm going to put this down here. Trick is, you ask a question, a good one, ideally, but any question will do, I guess, and you get to take one. And there's 2 varieties, so you get to pick between nut and something else, and I think cherries. Right. My name is Silviu Niculita. I am the Chief Technology Officer of a software services company that has a fairly big presence here in Romania. We've got 2 offices in Cluj, 1 in Brașov. We do a lot of work around data warehousing and big data. And over the last couple of years, we've started delving into machine learning. We don't do it in the cloud yet. We do it on premises, but machine learning and Azure is one of the alternatives we're looking at, because doing it on premises is very, very problematic. It's not fun. So at the end of this presentation, my goal will be for you guys to have a decent understanding of what machine learning is, how easy it is to do it in the cloud, in Azure in particular, how easy it is to publish a trained model as a Windows service that you can then very easily integrate into your sort of line of business applications. Okay. And this is not on for some reason. No? Okay. First problem of the day. Right. Who here uses machine learning? Right. Just one person. Who here knows what machine learning is? And if you don't, that's not a problem. I'm going to define the concepts. Okay. So what I'm going to do here is I'm going to try and define machine learning, give you some historical perspective over how it started and why we'd want to use it, give you examples of business problems that can be very, very effectively solved through machine learning algorithms. Then we're going to move on to Azure ML, which is Microsoft's brand new offering in the space. I say brand new, but it's actually, I think, about 6 months old now, right? It just came out of preview, but nonetheless, it's still available in just 1 data center in central US, which is a bit odd, but anyway. I'm going to have 1 or more demos, depending on how much time I've got left, because I really want to finish at 3 p.m. when you guys want to go home, probably. We're going to do a recap. We're going to draw some conclusions at the very end, and hopefully time for Q&A. Remember, I can't take that home. Right. What is machine learning? There's a trend in using the Wikipedia definitions, but that was too long-winded. So I went with something that Tom Dietrich said. He is a distinguished professor, I think, at Oregon State University, and he is one of the luminaries in the area of machine learning. So machine learning is, right, the goal is to build computer systems that can adapt and learn from their experience. Right. That's all it boils down to. There's a lot of mathematics and mathematical analysis that I don't pretend to understand, but you'll see that Azure ML democratizes that, and you don't need to be able to do linear algebra or any of that sophisticated stuff in order to be dangerous with Azure ML, right? So it's all about using the past to predict the future. If you can do it accurately, all the better, because if you don't, you're better off just flipping a coin, right? And here are some of the industries where machine learning is very, very heavily used, right? Very first one, so this piece works, right? Okay, churn analysis. This is something that companies with very, very large numbers of clients do. Think, for instance, of a cell phone carrier, right? They could potentially look at the data about clients they've lost and notice a pattern around those folks. Notice that, hey, this guy was paying me 20 euro a month, and he, for the past 6 months before he canceled his contract, had only been using about 10% of his minutes or data plan or whatever else. And it behooves me to call him 5 minutes into him exhibiting that behavior and to incentivize him to stay by giving him a subsidized iPhone, right? So that's the business case behind that. Social networks are essentially just big machine learning algorithms, right? Their input is your interaction with them. As soon as you like something or you check into something, they develop a better model of you, and it means that they can better target you with ads, right? My wife has picked up on this recently. She no longer uses Facebook as, to keep in touch with friends or anything like that. She uses it as her own personal product discovery mechanism, right? Because Facebook knows her probably better than I do. and it starts serving her up ads with stuff that she often ends up buying, which is not always a good thing. Recommendation engines. You've probably seen this on e-commerce websites. You buy, I don't know, a plasma TV, and it says, hey, maybe you might be interested in also buying these cables and a surround sound system and these things. There's nobody sitting in there sifting through thousands and thousands of products trying to match them together. That's all done by an unsupervised machine learning algorithm that sees what people tended to buy together at the same time. Based on that history, it tries to upsell you, essentially, right? I'm going to skip through the rest of these. Equipment monitoring, right? This is all around preemptive maintenance, right? Say you have lots and lots of trucks, right, transporting goods back and forth, and you notice, based on the logs of outages and breakages of your trucks, that this particular make and model, right, 2012, I don't know, Mercedes something or other, tends to break after 60,000 kilometers, right? This particular part breaks, right? So you call them in about 5,000 kilometers before that tends to happen, and you do preemptive maintenance on it, right? So you replace that part. You no longer have to tow the thing that broke in the field somewhere. You're not liable for delays in you delivering the goods and services and whatnot, right? Advertising analysis is where we at ReUp in particular use it. This is all about matching people more accurately with products and services that they might be interested in buying. Fraud detection, right? This is all about looking at trends in your purchasing history and noticing when you seem to be doing a transaction that doesn't really belong there, right? And I was actually a victim of my bank not having good fraud detection because my credit card was compromised a few months ago. It was very annoying. And I think my bank could have very, very easily prevented it because within a couple of hours of me purchasing gas, somewhere very, very close to Cluj, I was apparently also buying pizza in Puerto Rico. How likely is it that I'm actually buying pizza in Puerto Rico at the same time I'm getting gas in Cluj? So that's, I'm not going to tell you what bank it is. It's just, let's say it rhymes with Pennsylvania, right? So don't use those guys. Right? I wish, right? Personalized insurance, right? I recently got a life insurance policy. My premium was calculated by a machine learning algorithm that got it as it inputs my occupation, my age, my medical history, and it told them, here's how much we're supposed to charge this guy, and add 10%. That's what it felt like, right? Some very, very interesting and creative uses of machine learning. Microsoft has a research lab in New York, and one of their hobbies is predicting the outcome of certain events, like the World Cup. I think they were very successful there. And also the Oscars, right? I went with the Oscars because those just finished. And their success is quite amazing, right? So, and they've been doing better and better, right? They went from 19 out of 24 to 21 to 20. It might look like, sort of a regression, but apparently everybody very, very surprised that they pulled this off because the Oscars this year were very controversial, something about a Selma movie not being nominated and Lego and whatnot. So I don't follow it, but apparently they did very well. Yeah. Okay, so close enough, right? And they do this by doing something called sentiment analysis. They pull in, articles and whatnot and blogs and look at what people are what's saying in reference to the nominees and being very, very successful and picking the winners, right? Another interesting use case is around retail, right? The New York Times, this is slightly older, but it's still fascinating, right? It's about a 10-page article about how retailers are using your purchasing patterns, which we hand over voluntarily, right? If you guys look in your wallet, you will see a lot of those loyalty cards, right, that they ask you to swipe. Most retailers do this these days. And it's happening in Romania as well, except it's on a very rudimentary level, right? In my case, if I bought detergent from one retailer about 2 years ago, and wherever detergent is on sale, I get a text message, which is not the best thing in the world, but they're trying, right? Give them a few years. In the US, they've taken this to a whole different level. And some of the data scientists at Target, which is a general purpose retailer in the US, built a data model that can predict, based on a woman's purchasing patterns, with a degree of certainty over 87%, if I remember correctly, if she's pregnant. And also roughly what month she's doing. Right. And there's a very interesting anecdote in the article. An older gentleman walks into a Target store around Minneapolis, and he's clearly very upset, and he asks to speak with the manager. Right, and the manager comes up and, yes, sir, what can I do for you? And he's very upset, and he shows him, listen, you've been sending my daughter, who, by the way, is only 16, she hasn't even graduated college, personalized coupons for baby formula and diapers and baby apparel. And what the hell is wrong with you guys? What are you trying to do? Are you trying to convince her to get pregnant by showing her pretty pictures of babies? They're not that pretty, not always, right? And the poor store manager can't apologize enough. And a couple of days later, the manager's feeling so bad, he calls the guy back to apologize again over the phone. And this time, the father's tone is completely different. He says, listen, apparently some things have been happening in my house that I wasn't fully aware of, and I'm going to become a grandfather in about 6 months. So, right? So this is borderline spooky, right? I'm not sure if I want my retailer knowing when I'm going to become a father, sometimes before I do, right? So they've got to be careful about these things, right? When can I actually use a machine learning algorithm or machine learning in general to help me solve a business problem? When automated prediction is possible, right? When we already have a lot of existing data. Right, good example is purchasing history, right, or medical records or accident information for the insurance field, for example. When your current system for calculating, for example, insurance premiums is based on quote-unquote magic numbers, some value that somebody dreamt up years ago and nobody remembers why they went with that. It's not really useful when prediction is not an important part of the experience there. You don't have past data. The user experience is governed by a lot of business rules. For instance, if you're like an online pharmacy, people bought this in conjunction with this, doesn't really apply, right? And you can't really create a predictable pattern. And here are the base steps that you would use, right? 1, 2, 3, very simple, right? To do machine learning, it's not that simple, right? You find a data set that you want to analyze. You clean it up, you build a model, and then you turn that model into an API, right? And my demo is going to be around looking pulling a predefined data set, which is the census, right? So recensământ in Romanian, right? People say what age they are, what race, what their job is, and based on that, we're going to try and figure out how much money they make, roughly. And at the very end, we're going to turn that into an API, and you're going to be able to plug in those attributes. Based on that, it's going to go, and with a fairly high likelihood of success, it's going to try and guess how much you make, right? Now, go down one level, right? This is a more refined workflow. We would define our business problem, extract our data, develop a machine learning model, which has, again, another level of detail. We would define our metrics. We would extract our features. We'd select values, fit it, and then evaluate it, and then go back and forth until we are satisfied with the accuracy of our model. We would deploy it. We would monitor its performance, and then we would start all over again because the universe changes. Right? Buying patterns change, and you all constantly need to update your model. Right? There's two major categories of machine learning. Roughly two, right? There's stuff that falls in between. There's supervised learning, where you have an existing set of data that you understand, and then you try to determine one or two values based on those. And then there's unsupervised learning, where you just dump some data into it, and you let the machine learning algorithm try and find patterns within it. Right? Income inference, which is going to be my demo, falls into this category. A recommendation engine for movies or for products in an e-commerce setting would be unsupervised learning. Right, Azure machine learning. Here's a problem we're trying to solve with this thing, right? Doing data science, which is a more pretentious term for machine learning, is very, very complex, right? Our experience with employing machine learning in some of the products we've delivered to our clients has been, very painful. You have to go to a company that employs data scientists. Those are guys with the long beards and academic background generally that have a very, very good understanding of advanced mathematics. You tell them what you're trying to do, you give them your data, they come up with they go off and work for weeks and months, and they give you back a model, which in our case was a COM component. So you guys are probably too young to know what COM is. Right, and we take that COM component, which is obviously a black box to you. You can't fine-tune it. You can't do anything to it. You build a .NET wrapper around it. You use CLR integration to stick it into SQL Server, and then you use it. And then you notice that it is horrible on performance. And you need a gigantic server that you put off to the side because it's just extremely resource intensive to do machine learning. That was my experience, and that's why I'm looking at this thing, because I don't want to go through that again, right? So it's expensive, right? You need to understand multiple tools, right? You need to be able to import your data set into some sort of data store, right? You need to be able to clean and prep it, right? Most of the challenge behind doing machine learning is actually cleansing your data, right? In my demo, we're going to actually start with a fairly clean data set, right? US Census, where you've got somebody pulling you off to the side and asking you these attributes, right? But other data sets are very, very junky, right? If somebody signs up for one of those loyalty cards at a supermarket, they might say their name is Mickey Mouse or Donald Duck, and your challenge then becomes cleaning that data and figuring out what bad addresses are and whatnot. There's actually a term to describe this part of it, right? So cleaning and preparing data. It's called yak shaving. You guys know what a yak is?
Yeah, it's a hairy animal.
Hold on, I'll show you. That's why this doesn't work. I didn't plug in the USB. Okay. So it's sort of a Mongolian cow type thing. And say, oh, good, we have internet. Right, so imagine trying to shave this thing, right? So you can imagine how painful this can be if people refer to it as, yak shaving, right? you've got to then do machine learning, you've got to do experimentation, and then putting a model into production is also very time consuming, right? So we basically at WIA, we outsourced this piece and we did this ourselves, and that was painful as well. And we've got scalability issues and all sorts of things, so it must get simpler, right? And that's where Azure ML comes in, right? It is a cloud-based offering that's designed to obviously simplify and streamline and democratize access, right, to mere mortals like you and I who don't have the very, very strong mathematics background to machine learning. So it also makes the access easier, obviously, to developers and data scientists. Some world-class machine learning algorithms come in the box, right? So they're just components that you quite literally drag and drop, right? So these are things that were developed within Microsoft by some of the Xbox and Bing teams, some of the vision stuff that they do around their Kinect product, right? And it also supports tools that data scientists and people that generally work in machine learning, they tend to use fairly exotic languages. Python you might have heard of, R not so much. It has its own IDE and it's very exotic.
It's something like a MATLAB.
Yeah, very much so, MATLAB. They didn't go that far. They're not supporting MATLAB. Now, in terms of the solution architecture, you have the Azure portal, which you guys have seen a bunch today. And this is where your operations team generally resides, right? They provision virtual machines for you. They do all sorts of things. So they would create a workspace so if you guys have a developer background, this would be TFS. This would be Visual Studio, right? ML Studio is a web-based IDE that allows you to do, obviously, machine learning. And this is where a developer / data scientist might live. You can pull data from HD Insight, which is Microsoft's implementation of Hadoop, through, I think, Hive queries, if memory serves me right. You can do Azure storage. You can pull data from your desktop by importing CSV files and then doing analysis of them. Once you're done, you produce an API that can be then consumed by web apps, mobile apps, and dashboards, and all sorts of good things. Right. What was that?
And it's just $1 a month.
Actually, tell you the truth, I'm not sure how much it costs. So the way you pay for it is per compute time. So that's how long your machine learning algorithm is running. And so this is the new portal that's very pretty. Unfortunately, machine learning isn't supported in the new one, so you have to go to the old one. You can make it black as well, and it's very nice with the what they call them, blades and whatnot. It's a very interesting visual metaphor. So you have to scroll down to the beaker-looking thing, machine learning, right? And this is your operations team doing this at this point, and they would go do new, quick create. Can you guys see that? Yes. It's reasonably good. Right, workspace. You just give it. So at this point, I'm creating a machine learning workspace. I give it a name. I tell it who's going to be using it, right? So this can be a live ID or an email address or that sort of thing. I can tell it what data center to deploy that workspace to. Just one data center, remember. And a storage account, which is just used for storing your imported CSV files and that sort of thing. I'm going to open an existing one because creating a brand new one takes a few minutes. And here you can do stuff like configuring the workspace owner, and there's some permission stuff as well somewhere around here. There you go, manage access. So you can collaborate on models, right? So this is sort of like Google Docs for machine learning. You have multiple people working on the same thing at the same time. And we're just going to sign into it, and it takes us to a different domain, azureml.net. Single sign-on, and it's moving me back. Right. Okay. And I've got an existing experiment that I'm not going to delete it because this one works. This is me practicing this morning. So in case I screw up, and go to the existing one, right? And remember I was telling you guys can use desktop data sets. So what you can do is actually import an existing file well, not this. I wanted to show you the supported data types. So you can do CSV files with headers, tab-separated files, zip files containing CSV files, and a few other formats. They don't support JSON or XML right now, but they're working on it because most apps use JSON these days, or BSON, or one of those things. So I'm not going to bring an existing CSV. I'm just going to create a new experiment here, and there's a bunch of samples in here, but I'm going to start with a blank one. And this thing is your design surface. You've got your toolset here on the left, and then your properties pane on the right. This is basically OneNote meets SQL Server integration services, right? They kept the metaphor from OneNote in the sense that this title thing here, first experiment, is actually going to be my experiment name, sort of like how the header in OneNote is what your page name becomes, and integration services in the sense that it's all drag and drop, and you interconnect components, right? If you wanted to bring some external data into your experiment, you would use the reader component, and here we go. And you can have it do HTTP requests for you, right? If you wanted to pull data from Twitter, for example, right, you could do a Hive query, point it to Hadoop, right, or HD Insight rather. You can point it to SQL Azure databases, blob storage, and whatnot, right? But I'm going to keep things simple, and I'm going to use an existing data set, right? They are kind enough to provide us with a bunch of, open source data sets. What was that?
Bill Gates RGB image with
This is brand new. I actually hadn't seen it. So you pull it over, and you use these connected things to visualize the thing. And, oh yeah, so it's pixels. Interesting. I hadn't seen this one. So the fun of using an online IDE is that it changes. And I actually started preparing for this talk a couple of weeks ago, and I'd done this demo, and then I think 2 or 3 days ago, they pushed a big update, and they changed the way you convert a model into a web service. And I had to scramble last evening and figure out how to do it again. So the data set I'm going to use is adult census income. So this is just a very, very small subset of one of the censuses that they do in the US every once in a while. And you can actually, obviously, visualize the data. And we've got roughly 32,000 rows in here and 15 columns. And you can see some of it, right? You can see people's age, working class, education level, marital status, occupation, race and sex, and this has to do with taxation level and how much they work, their native country, and their income. Right. So the name of the game right now is basically trying to guess the column based on some of these other ones, right over here. And if you remember, I mentioned yak shaving earlier, and I traumatized you guys with that picture. This is a fairly clean data set, but some of the columns, I think native country, has some missing values. Right? You really don't want to have missing values in your training data set. And machine learning ML makes it very easy to get rid of them, right? So we're going to do clean missing data, right? So there are 100 components in this thing, and they're fairly logically structured, but browsing through this thing can be problematic, so I just search for most of the things I want to do. So you grab it, and you connect it down. And you grab this guy, and you tell it to substitute missing values across all columns, right? I could tell it to just do this replacement on a subset of columns, but I'm just going to let it do all of them. And I know that it's country, and the replacement value is not going to be 0. It's going to be no. We could do something fun like Narnia or a made-up country, but just stick with unknown, right? So this technically is a working model, right? I can save it, and I can run it. And let's see about zooming in here. Okay. And this is obviously not going to do anything because it's a static data set, but this run, and I can visualize it again. And if I scroll over to native country, missing values goes down to 0. And if I scroll, I should see unknown, right? So surprise, it works. Scroll out. Next, I'm going to want to do a split. And that just as the name implies, is going to partition my data into 2 buckets. When you're doing machine learning, you want to use a portion of your data to train your model, and then another portion of it to actually validate it, right? Because I know that the data I have for those 32,000 individuals is true, right? Hopefully, right? They didn't lie on the census. But that's not my problem at that point. So I'm going to take this, connect it here, and I'm going to do an 80-20 split. The default is 50-50, but in data mining, we do 80-20. Right. And that means 80% of my data is going to flow through this port, 20% through this one. And at this point, I am ready to train my model. Okay. I'm going to train it with 80% of my data, and I need to pick a model, right? Or rather, a machine learning algorithm, and I'm going to pick one. Initialize model, and I happen to know that I need to use a classifier, and I'm going to do a 2-class sort of binary average perceptron. That sort of sounds like a Transformers character, right? 2-class average perceptron to the rescue. Okay. And oops, I actually forgot to do something here. So I've got 15 columns right now in my data set. That's far too much. I'm not going to use all of it. So what I'm going to do is I'm going to project some columns. So that this basically just lets me truncate the set of columns that are going to flow down below this level, right? So I'm just going to stick with age, with education, with occupation. So it's just the fields that I feel would have an impact. Race and gender, unfortunately, are going to impact income. And 1, 2, 3, 4. Let's do another one. Let's see marital status, right? Hopefully married people make more, because I happen to be married. So and I definitely want to make more. Where's income? Because we definitely need income as well. Oh, here it is. Okay. So started with 15 columns, cleaned out the missing values, split it, and this is the incorrect order actually, because we want to do, I want to put these around. Going to do a column projection, because otherwise I'd have to do the projection twice. Okay. And hopefully, oh, and you can columns. If you double click on the thing, you can add a comment on the component. And this saved. So we're going to split it. We're going to have this thing. And we're going to train the model. And we're going to have to tell this guy what column I wanted to guess. And the last thing I have to do is actually score the model, right? To see how well it did, right? And here's where I'm actually going to use the split. So I've trained this guy. So theoretically, at this point, this magical component knows how to guess your income based on those other 6 or 7 columns, right? And I'm going to make it play the guessing game against that 20% of actual data, and we're going to see how well it does. So we're going to run this thing. And this guy is going to take anywhere between 30 to 90 seconds. Everything that needs to run is going to have this sort of clock face on it initially. And then you're going to see some sort of spinning thing, and then it's going to go to a green check mark. So there you go. This is running. Everything that's part of my model and that needs to be run goes into this sort of global Azure ML queue, and Microsoft has worker roles sitting there behind the scenes. and your stuff gets queued in, and as soon as there's room in the queue, it'll actually execute your stuff. So while these things are running, it's an actually good time to ask questions.
Is there any problem this SSS or you could write some code like to say C#
Yeah.
or Visual Basic?
Not C# and not Visual Basic, because those aren't the tools of choice for data scientists, but they do have
You can use
R language models and Python language models, right? So no C#, unfortunately, right? It's not really a language that lends itself well. It also doesn't have the libraries that let you do the sort of thing that data scientists typically do. Okay, so candy for you, Luigi. Yeah, go ahead.
Does it predict only numbers or also collections?
You can do so. I'm gonna I actually didn't show you guys the data set clearly, but income is not an actual number. It's binary. It's equal to or greater than $50,000 a year, and then lower than $50,000 a year. And that's why I'm using a 2-class average perceptron, right? So 1 and 0. You can have multi-class ones as well in here. Machine learning.
Still just a classifier.
Yeah, multi-class. But multi-class is actually just an aggregation of binary classifiers.
There's also clustering.
Yeah. So theoretically, we could do, guess people's favorite color if we had that data set. And that's obviously not just 1 and 0s. It's red, blue, green, whatever, right? So that is supported. Yeah.
About overfitting your model, you split it in 80/20.
Yeah.
Does that go for most situations? Or
Yes.
another question here, how many input data do you usually need so the model isn't overfitted for that specific data set?
There's no generally applicable answer to your question. It obviously depends on your data. It depends on the quality of your data. This being census information, it's reasonably accurate, right? If you had something that was aggregated from multiple data sources like we do. We do a lot of work in database marketing, and we constantly have to purge Mickey Mouse and Donald Duck, and people have fake addresses in there, and there's 20 million different ways of spelling an address, right? So obviously, the more data you have, the better. The 80/20 rule is something I've seen used consistently, and it seems to be sort of a best practice to train your model with 80% of your available data and then evaluate it with the other 20%. So I would say that yes, that's sort of a golden number there. Okay. Other questions? Yeah.
Yeah, so you said that the Azure ML supports Python and all.
Yeah, yeah.
So I have, for example, a classifier for Twitter sentiment analysis. Will I be able to fully remove it and use the computing power of Azure?
Yes, yes. You might have to. So you're obviously. It's sort of like SQL Server Integration Services, where you drop in an execute SQL script piece of it, right? That execute SQL piece has to mesh nicely, right? So it's not going to be copy and paste strictly. You're going to have to. Where do I want to go? R script. So it's very simple, and you've got an editor in here, right? And you've got input ports, and you have to map them to data sets, and at that point you consume them inside your R script. So that I would expect that this would be the only sort of customization that you would need to do in order to get this thing to work in here. And there's one of my reference links is actually to a presentation about Azure ML that was held at TechEd, and one of the demos is around doing Twitter sentiment analysis across, I think, 140,000 tweets and scoring them from 0 to 4 in terms of positivity, right? If somebody's got a frowny face, it's 0, and if it's yay, and it's more than that. Okay. So back to this. So lots of candy to hand out. You guys, I'll do that at the end.
On the various classifiers,
Yeah.
And by stochastic models that are, do they have actual specs like to explain how they were implemented? I know some of them are like well-known classifiers in literature, but some classifiers and so on,
So,
some variations
yeah.
existing. So
Yeah.
is there like some?
Yeah, there is fairly good documentation, right? I'm not a data scientist, so I don't understand half of what's going on in this guy. It's everything I know about perceptrons is these are the oldest classifiers that I think were invented in like the 50s or the 60s, and they've been around forever. So this is sort of like, oldie but goldie essentially, right? It's, the ABBA of machine learning, if you will, right? And they have them split into 4 different categories, right? So they've got regression, clustering, classification, and anomaly detection. This one was added just recently, and every single component has a fairly extensive help section.
Okay, so they're like
Yeah.
properly documented from the same.
Yeah, they are. I mean, I would assume. I hope so. But you've got to take everything I say with a grain of salt. I have no idea, so I'm going to just go with the default. The learning rate, maximum number of iterations, and random number of seed is. Hopefully somebody came up with good default values, because I'm not going to understand the thing. So I'm strictly a consumer of machine learning, not necessarily a connoisseur. So at this point, it's scored my model, right, using that 20% of my initial data set, so 6,000 out of the 32,000 roughly. And I've got my 7 columns that I gave it initially, right, income, plus these 2 that were produced by my model, right? And this is actual value, this is the value that it guessed, and this is the scored probability, right?
The degree of confidence of the model within the guessed value.
Exactly, that's exactly right. And everything that's below 0.5 goes to 0, and anything that's above 0.5 goes to 1, right? So since this is 0.29, it's going to guess lower than 50,000, lower than or equal to, right? And it's doing a reasonable job, right? Here's a mistake. And you'll see these things. Good news is we don't have to scroll these things and manually calculate them. There's an existing component that does this very nicely for you. We can, where is that thing? Evaluate a model. So we drag this down. We run this again. Okay. Questions? If I don't get questions, I'm going to show you pictures of my daughter. She's very pretty, and she's 8 months old. So here you go. Here she is around Christmas.
Did your wife buy from Target?
No, I was lucky enough to learn about it early on. And here she is eating earlier this morning. Here she is, come on, smiling. Right. Here she is again, looking suitably surprised there. I'm also trying to turn her into an internet meme. You guys know 9gag, right? Right. So this is out of the a couple of team members and I are going to do an internal presentation at RIA about AngularJS, and I produced that for that. Anyway, so this is done, right? And it's good because I'm out of pictures. And we're going to visualize the results and more machine learning, right? More sophisticated stuff. The most important metric that we have here is this guy. It says AUC, area under the curve. And the simplest way I know to explain this is if we were just flipping a coin, odds are we would get it right about 50% of the time. And our performance would line up fairly closely to this diagonal line. You can see our algorithm is doing slightly better, right? The area under the curve is 0.86, which is, 0.87, which is good. If you can get close to 0.9, you've got an excellent algorithm. If you get really, really close to 1, there's something wrong. You're overfitting your data, just like he was asking. So, you've got problems there. And this thing is called the confusion matrix because it confuses people, and because the scientists like using terms like matrices. So I've got a slide here that sort of tries to explain it. Here is the truth, so the actual values in the data set, 1 and 0, and here is what we guess, right? Positive and negative. We obviously want to guess 1 when the actual value is 1, and want to guess 0 when the actual value is 0, right? And data scientists use stuff like precision, which is a ratio of true positives over true positives plus false positives, and recall and accuracy to actually gauge the accuracy of a model, right? We're not going to do that. You're just going to have to take my word for it that 0.87 is an excellent result. And what I want to do now is actually show you how easy it is to compare various algorithms, right? So this thing supports copy and paste. Nice, right? Oh, no. It doesn't. That was yeah. No, it doesn't work. It doesn't do undo. So what I'm going to do is I'm going to scroll out so I can actually see this thing better, and I'm going to reduce this back, scroll back in. So this, I'm going to not use, so I'm not going to use this initializer. I'm going to use a different one. Yeah, so we're going to use,
Still a 2-class.
well, yeah, it has to be a 2-class in order for me to be able to actually,
The 2-class neural something is the...
the neural network? Yeah, sure, that's a good one. As if I know what the, but any, right? So the same thing, right? 80% of my data is going to go to both training models component. They each get their separate initializer. We're going to train the model, we're going to score it, and then we're going to evaluate it at the very end. And it's running. And while it's running, I'm going to hand out candy. That's the way I ensure you guys don't fall asleep. There you go, and I think one here. And did I miss anybody? Hope not. Lucian. Oh, Lucian. I wasn't going to give you one, but there you go. Okay, that's supposed to happen. So let's try refresh. I haven't had that happen before. Okay, that's weird. Please reopen. That's not nice. So, okay, my first experiment. Very unusual. Clearly it has bugs. Right, so, oh, this is missing. Cancel. No. So, cancel. I forgot to connect. Unfortunately, it doesn't really, it doesn't have edit and continue, at least not yet. I'm not sure if they're going to add it or if they can easily add it, but you're basically stuck starting from scratch. So this is guys going to run. I should have used up all my baby pictures in the previous run. Okay, so the first one, right? Our perceptron is done, our neural network is running, we're training the model. I'm running out of time, so I'm going to have to really start moving. Come on. The nice thing about Azure ML is it's very inexpensive, right? So if you get a trial account, you get, I think, 75 euros of credit per month for, I think, 3 months. I've been playing with this for weeks, and I've used €1, so it's really cheap as compared to something like SQL Azure. You know, I did a presentation about SQL Azure in December, and I used up 75 euros in 5 days. Because if you want to play around with the premium databases and use active geo-replication, it's phew. So this is cheap. And yeah, I do. That's true as well, right? So ideally, right, for a good demo, I would have wanted these things to be more different. This seems that they're pretty close together in terms of performance, right? So the left-hand one got 0.876, the right-hand one got 0.877. Right, so you've got to go down to third decimal point to find a performance difference. But technically, the right-hand side one did better. And because it did better, I'm going to reward it by saving it as a trained model. My first FIRSTTM, right? And at that point, it becomes a trained model that lives in here, right? And since I've already trained it, I don't need this piece. I don't need a lot of different things. I don't need to evaluate it because I know what the area under the graph is. I don't need my trained model. I don't need the thing, right? So I'm going to drag this guy down, and oops. So I'm gonna actually I needed the evaluate piece. Evaluate model, run. Just connect. No, it's not evaluate model. Sorry, score model. You can tell I'm trying to rush to finish in times. Okay. And we just connect it to, doesn't really matter which one. And we run it again. No, well, it's already trained. So at this point, all of its expertise in terms of guessing income based on those 6 or 7 columns is already embedded into this component, right? So it knows what it's doing at this point, hopefully, right? So you see I have my 9 columns, income and scored label. And since it's doing so well, I'm going to trust it, and I'm going to take out the income column because I don't need to pass it down anymore, right? And I am going to do another projection because I don't really need to have 9 columns as my output. All I need are scored labels, scored probabilities, right? Because I'm just interested in what income the model thinks somebody has and how confident it is in that prediction. And another thing I'm going to do, right, so we're almost done here, is I'm going to productize this thing and turn it into a web service. And hopefully I remember how to do this. So I'm going to have an input and an output that hopefully fit. So just put them over here. And I'm going to, so the web service input is going to go into here, and the output is going to go like this. Right? So, and I can toggle to web service mode. So a web service is going to get as its parameters those 6 or 7 columns, somebody's age and marital status and all sorts of other information, and it's going to tell me what income they think they make and how likely it is that that's actually a genuine value. I'm going to run this guy for I think the last time. Great time for questions, because we're not going to have time at the end.
At the moment,
yeah.
Website is exposed. After the model is trained, so it's going to inspect and analyze the whole data again.
Oh, obviously, training a model is a point in time thing. After that, once you expose your web service and you actually convert it into, once you add a production grade endpoint to it, because the first one you add is going to be throttled because it's sort of like a staging endpoint that you just test with, it's going to be a split-second thing to actually get a result back.
Okay,
Was that your question?
Want to update, let's say, the prediction based on the data,
Yeah.
then we have to convert
Yeah, there's a link. I'm going to show this at the very end. There's a link between the web service and the model, and you can go back and update the model. And they're actually going to add a programmatic way to do this through API call, so you don't have to do it manually, right? So let's say you want to update it on a daily basis. You want to be very aggressive about training your model. There's going to be a programmatic way. Right now, you just have to go in and do it manually. Right, so this thing is done, and I'm going to publish my web service. Let's just call it my first experiment. That's fine. Oh, candy at the end. So here's my web service. It's got an API key, obviously, because it's publicly accessible. I get 2 endpoints. It produces RESTful APIs, which is annoying to me because I'm a big fan of SOAP. You can tell how old I am based on that statement. So yeah, there's a request response, and this is the mode in which you get a split-second response time. Right, actions, milliseconds realistically, once you add a production grade with the 99.99% SLA to it. And there's also a batch execution piece where you give it a bunch of records that you want it to score, and then it'll actually save that result set out to, I think it uses Azure Blob Storage, so it's actually a text file. And the second one is asynchronous. But there's a handy-dandy test model in here. So where, let's say, somebody that's age 30, that's got education, and I don't know what the accurate values would be for the thing, so I'm going to have to go back here and copy and paste some of them out. Let's see. Visualize. So, yeah, so masters would be one, marital status would be divorced, occupation would be, let's say, this thing, and relationship would be husband. That would be a good value, and then I think that's it. Okay, get back to the web service. Test it again. Let's say age 30, education, masters, and marital status husband, I guess. Oh, married. Okay. Married, occupation, thing, race, white, I guess, sex, male, and run. And it's going to run. And the production one is going to be faster than this thing. Remember, this throttled. So it's going to say that I make over 50,000, and with fairly high. It's a good thing I got that master's degree then, right? And if we test it again, let's say somebody who's 50, who just went to college, who's divorced. His occupation is still the same thing, who is, I'm wary to put anything in here because that might be politically incorrect. So yeah, it's, predicting income based on these attributes is always a dicey thing. So there you go. It's less than 50%. This is cutting it close, but 50%. Right. These APIs come with a help page. You can see the URL you're supposed to post to. You get sample requests. You get there's some C# code in here as well, right? So this is the code that you would just copy and paste into Visual Studio. As long as you get NuGet, I think it uses Web API client to do these requests. So just copy and paste, and there you go. You're integrated. You're using your web service at that point, right? And you can configure the thing. Change the name, the description, add some more appropriate names for the input and outputs. And if we go back to this thing, where are the web services? Oh, here we go. This guy, you can see the throttle level is high. That's why it actually took a bit of time, right? So it got close to a second there. If I was to create an additional endpoint and set the throttle level too low, it would actually deliver those split-second response times, right? Last thing I want to show you, these models can become very, very complicated, but you actually decompose them. They're very easy to understand, right? So sort of like a very complex SSIS package. If you take it one piece at a time, it's easy enough to understand what in the world it's doing. And a very interesting one is, I like this one because it is very pretty, right? Beautiful. So this actually looks at weather information. Whoops. Zooming too much. Weather information and flight delay information in order to actually try and predict how likely it is that a flight departing from a certain airport is going to be delayed. And if you it looks, let me fit it right. So it's huge, but nothing that sophisticated about it. If you just drill down deep enough. Whoops. So you start off with the data set, you do a column projection just like we did, you clear missing data, you do some mathematics. In this case, this thing is rounding down is truncated the minutes out of the hour, and it's doing some more math operations. It's going to do joins between different data sets and splits and whatnot, and it's going to tell you with a reasonably high degree of certainty how likely it is that your flight is going to be delayed.
Actually, I heard of a more fun API which tells you whether your flight is gonna predicts whether your flight is gonna crash or not.
Yeah, that's fun. That's an interesting API to use, especially if you're going to fly Malaysian Airlines or something, right?
Yes, yes, it takes like inputs airline,
Okay.
machines, the actual airplane that you're flying, and the airport that you're
Well, if it's Malaysia Air, it's probably got a hard-coded line in there. If Malaysia, then one. Right? So very, very quickly, I'm going to go through these things because we're already 5 minutes above. Web-based IDE, very, very powerful. Cross-platform, obviously. I was using it in Chrome, but it works just as fine in IE. You can, I didn't show this thing because I would have needed a co-presenter, but you can have multiple people working on a very, very complex model at the same time. Right, end-to-end workflow for data science. It has awesome machine learning algorithms that they keep adding and adding to, and if you're really hardcore and you know R, then you can use those. You can build, you can sort of bring your own as well. Okay, rapid experimentation. You can, as you saw, you can very, very quickly take a trained model and expose it as a web service. And I think there's actually a marketplace as well. Everybody's doing marketplaces these days. So if you've got an awesome, I don't know, model to predict risk for the insurance agency, you expose it as a model, and there's a billing model, billing mechanism there incorporated as well. So you can start making money, not models, well, money from your models through Azure. Right? The rule of thumb, train with 20%, test with the other 20%. The compulsory Gartner slide, no self-respecting CTO would end a presentation without quoting Gartner. And the bottom line here is that as organizations mature and grow, they want to move up the value ladder, right up from business, from traditional BI, where you're building OLAP cubes and looking at what happened in the past and how many widgets I sold in this region across blah, 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 to trying to predict the future. Right? What Azure ML is trying to do is, you can see obviously this is value, this is difficulty, is trying to lower the gradient on this thing, right? So democratizing access to machine learning. Right, references and resources, most of the nice animated slides that I showed today came out of these 3 sessions that were delivered at TechEd in November last year. This guy, this one in particular, is delivered by a college university professor out of the States that really understands the maths behind these things and explains all of the models, and there's going to be all sorts of concepts that I honestly didn't understand. And Microsoft Virtual, the MVA has an awesome 3-parter on doing machine learning, and their demo is actually an unsupervised learning model, right, which does, I think, movie predictions based on the IMDb data set. It does stuff like, oh, if you liked Iron Man, you're most likely going to like, I don't know, Spider-Man 3 and Star Trek or something. Right, questions? I still have 3 boxes of candy. Yes?
Any competition?
Not really. Not yet, anyway. It's a very compelling product offering. So no, not quite like this. Maybe in the future, but they've set the bar pretty high in terms of what you can do, right? It's an all-in-one. It doesn't get much easier than this. You just sign up for a trial, start, playing around with some of the best machine learning algorithms in the world.
Do you test other tools?
Well, yeah, I mean, we do this, right? We do this, but there's nothing quite like it, right? So typically the machine, using machine learning in industry is very, very tough and very complex and very expensive, right? So sort of like what the experience I described, where you go to an outside group that specializes in machine learning, and they give you something in a programming language that you don't understand, like R, which doesn't scale, which is a huge resource hog, and you spend months and months trying to translate the damn thing from R into C# or something that you can run on your existing infrastructure. So it's painful to do this right now.
Yeah, there are other tools like Veka or RapidMiner or Radu or something like that.
Yeah, but they don't, it's not an all-in-one solution, right?
I'm not
drag and drop, like.
Yeah, I mean, yeah, the separate pieces of the workflow that I showed today exist, obviously, right? But they're not sort of an all-in-one type thing, right?
So how is the payment done actually? Because what I understood is that, okay, there are certain algorithms
Yeah.
already implemented there.
Yeah.
But of course, others better might come in the future.
Mm-hmm.
And I guess whoever develops a certain algorithm
Yeah.
wants money for this algorithm, not
Sure.
the same price for everything they want.
Sure. So you don't typically charge for an algorithm. You expose it as a web service, right? And you charge for use of that web service. In terms of how you pay for Azure, there's compute time. So for however long the circle is spinning, right, that's how much you pay for. And it's not that expensive. Obviously, that's a linear function of size, hopefully linear, not something else, right? So the larger your input data set is going to be, the more it is going to take to train that model, right? So you pay for that, and then once you have a trained model and you expose it as a web service, I think there's a per call charge, but it's fractions of pennies, so it's not that expensive, right?
So you as a developer, let's say,
Yeah.
you pay for the algorithm, and you are paid for your model, for your.
No, the algorithm is free to use. It's just like you don't pay for the button control in Windows Forms, right?
Yeah, but that's what I'm saying. Somebody who will create a new algorithm, which is
Yeah.
more clever than anything is was
Yeah.
done before.
Yeah.
He will want more money for.
Oh, sure. Yeah, that's true. If somebody comes up with an awesome R script to do what I just showed in a more accurate manner, and if that level of accuracy is a key differentiator for you, so if you want to get above 0.95, right, area under the surface there, you're probably going to have to pay a licensing fee, right? But Microsoft's kind enough, just like with going back to my Windows Forms example, if you want to have nice buttons, you're going to give Telerik some money. If you want to have really cool,
Everything you see here is free.
yeah, everything is free, right? Yeah, everything is free. You just drag and drop it, and if you want to go to a one of the best data scientists in the world, like the guy that did the Oscars prediction there, he's going to be expensive because yak shaving is an unpleasant activity. And those guys have very good, very solid mathematics and data science and all sorts of interesting things in their professional background there. So they charge a lot for that. But it's essentially going to translate into just a few pages of R code. But it's valuable R code there. Okay. I'm officially out of candy, but you guys are welcome to keep asking questions. Yeah, go ahead.
So does this solution support unsupervised learning, like algorithms?
Yeah, it does. It does support unsupervised learning as well. I just didn't demo it because I barely had enough time to do one, but there's there you go. You guys get to share. And there are samples in here for unsupervised as well, I think. A good one would be samples, IMDb, no, movie maybe. Yeah, anyway, they're in here. I'm not sure what they called it, but yeah, it's somewhere in here.
2 pages.
Oh, 2 pages, okay. So they've added more. Recommendation, movie recommendation, right? So this would be a good example of that. Yeah, this one's nice as well. But you click this thing and you see what OneWorld is doing, right? So we join so that we can give the recommender movie titles rather than IDs, which is always nice. If you like movie 37, you're going to love 42. It's not always going to be very helpful. So yeah, you can do both classes. I just showed the one because it's more interactive and it's okay. More questions? Yeah.
About scaling out.
Yeah.
So if you have a big data set, let's say hundreds of millions of
Mm-hmm.
records, does the Azure engine automatically scale out for you? So the whole processing.
You mean the training piece of it? Yeah, it does. It does.
You
It.
have
Yeah.
to do a bit of
Yeah, it does do that. Otherwise, you're going to be stuck here for weeks waiting for the thing to finish. Yeah, it does do that. I haven't really, to tell you the truth, I haven't tried with anything other than the built-in stuff. but the documentation says that it scales very well. And that's actually one of the key differentiators. You don't have to worry about, is my server going to be big enough, and how long am I going to be sitting here, and do I have to start this on Friday evening so that it's hopefully done by Monday morning, that sort of thing. No, it's, yeah.
What about the API we expose?
Yeah.
Is that a separate website or something in Azure?
It's a separate web service, and you're going to pay for calls to that web service separately, yeah. But once it's done, it's done. It's there.
So basically, if we need to scale up, we can.
Oh yeah, that thing is as a web service, you scale it out as you want or scale it up. It's just like any other web service, except it executes a model behind the scenes. And there's a link between, I think this was one of the questions, in here, maybe in here. And because I think somebody asked me, so the web service, and once it's a web service, so here's the parent experiment, and you can, even once it's deployed, you can actually go back to the parent experiment and update it. So take this guy out and replace my first trained model with my second and third and so forth trained model. You just save this, and that obviously propagates into your exposed web service. Okay. More questions? No? Good. In that case, thank you for bearing with me. Only 15 minutes more than what